Okay, as always, when I'm simplifying complex fractions, I like to work kind of exclusively with the numerator, combine that into one fraction, then come back and work exclusively with the denominator, and then go from there. So thinking about my numerator of 1 over x plus 1, again with a whole number, I will change that to be written as 1 over 1. Any whole number can be written as over 1. And then I'm going to look for a common denominator. So I'm thinking to myself, what does this denominator have that this one needs? Well, this has an x, this needs an x. And so I'll multiply by x over x. And then what does this denominator then have that this one needs? Well, this has everything from over there. This has 1x in the denominator. It already has an x, so I don't have to fiddle with the 1 over x at all. I'm going to rewrite. I like to write out all my steps. And so we're going to be left with 1 over x plus 1 times x is x. All over 1 times x is x. Now that we have our common denominator, I can rewrite as 1 plus x all over x. Again, I'm going to write this in standard form so that the variable comes first. And so we'll rewrite as x plus 1 all over x. Now I'll go back and consider the denominator of 1 minus 1 over x squared. Again, I'll rewrite as over 1. And then I consider what does this denominator have that this one needs. This has an x squared, this needs an x squared. And so I'll multiply by x squared over x squared. What does this have that this needs? There's nothing that this has that this needs. This has everything it needs. We have 1x squared here and we have 1x squared there. So now I'll rewrite. X squared times 1 is x squared over x squared times 1 is x squared. Take away 1 over x squared. Combine that into one fraction. X squared, take away 1 all over x squared. So what I notice here is this x squared minus 1. And that's a very special binomial. That's a difference of squares. X squared is a perfect squared and 1 is a perfect square. And I know that a difference of squares is going to factor into x plus 1 times x minus 1 all over x squared. Okay? From there, now that I have 1 Now I'll multiply straight across. 1 times x is x, and then the 1 times the x minus 1. Some kids get confused when they see x over like something like this with an x minus 1, and they're wondering, can I reduce this x and that x? And the answer is no. X minus 1 is its own unique factor, and so is x. Remember, if this was a number, pick a number, let's say you chose 3. The numerator is 3, but the denominator is 2, and you can't reduce a 3 over 2. So these are actually two different numbers here, and you can't reduce that x and this x. because that minus 1, it binds itself to that x there. And they have to be exactly the same on the top and the bottom. And so we're done.